Good afternoon, everyone.
Good afternoon, Miss.
Hi, Miss.
Good afternoon, Miss Green. Kesana. Not hearing you, Kes. I'm just mouthing you that I haven't seen a response from you read the last class. I hope all is well.
Hi students, how are you doing this afternoon? Mrs. Hennihan, how are you?
Hi, sir.
Thanks,
Doing
sir.
good. How about you?
Good afternoon, students. All right, so Mrs.
Afternoon,
Hennihan, I
sir.
see that you're speaking, but I'm not hearing you. Is there anybody hearing me?
Yes, sir.
Or maybe it could be me. Okay. Okay, so I guess it's my device. Let me disconnect. And are you hearing me now? I mean, you're hearing me, but all right, Mrs. Hennihan, you're speaking. I am not hearing you. Okay.
No, I'm not speaking. I'm speaking. Mr. Shand?
I'm hearing you now, loud and clear.
Nice.
How are you doing today?
I am good. I think we're all concerned about you.
Well, thanks for the
You were
concern.
and still are.
Well, I am wellish. Mm. Well, so up to when the class ended on Friday, I was still waiting to have 3 different X-rays to be done, neck, lower, and upper back, because I was having pains, in those areas. And as the time progressed, the pain, was intensified. Um, my wife too was in the car, and she too had, pretty much the same symptoms. So well, I had to wait in line, for her to have done her scans first, and then I did mine after long process. But long and short is the scans came back normal, but the doctor recognized for both of us that he saw evidence of muscle spasms. So he gave us some muscle rub and tablets. So why I said wellish is because, I'm still feeling a little bit of neck pain, not as excruciating as it was, into Saturday, Sunday. It's kind of dissipating, but it is still there. So I'm giving God thanks. And as you asked about that, Miss, I was really out of it afterwards because I was tired, never had anything to eat, and la di da la di di. And then I got up early Sunday, Saturday morning, to find out that one of the little young ones that I normally watch on TikTok perished into a motor vehicle accident. And then,
Yes.
right, and then Lexi, and then I was talking to a virgin of mine who sent me a picture of an accident that happened in Hanover, where people were cut in two. And I'm saying, is it that the devil has unleashed his spirit because the place opened up now and COVID and so many lives were lost? And I don't know, but it's just something that we just have to be very careful about. I did nothing wrong. I was stationary, waiting for the line of traffic ahead of me to go, and bam, somebody came and hit me. And this young lady, this jute man with his foreign passengers, I actually saw the video of the accident, and he was just doing what it is that he was supposed to be doing, and somebody just came and just cut him short. He died. And then today, I'm hearing on my way from campus today, I'm hearing at William Nib, 2 boys having some altercation, and one took knife and stabbed the other, him dead, and the other on the run, and police catch him. And I'm saying to myself, guys, mm, the
It's
devil,
not worth
it's not
yeah.
worth it. It's not worth
It's
it. The
not
devil is
worth
just out
it.
there. That's not worth it. You know, the devil out there, and you know, they can call me an idiot because I will walk away from any contention. You know, it's life is just life is just it's so short. Death is so final, and you know, we live so carelessly. Today I was driving, and I feel paranoid around the steering wheel. I am watching my rearview mirrors, and I'm saying, God, do make the driver behind me be as careful as I am, and cover me, and cover the one in front of me, and cover those ones, Lord, who not supposed to be on the road, but them there. It is just a frightening experience. But anyhow, I will not live my life in fear because fear is not of God. All right, guys. Thank you, Mrs. Henningham, again for ably, leading the charge on Friday. Thank you, students, for turning up. I have a few concerns, though, students. Concern number one, um, it is really not polite when you're having a conversation or somebody's having a conversation with you and you are, well, I'm going to say ignoring the person. No, sir, we're not ignoring here, listening, but you're not responding. And to be honest with you, I always commend you guys, even in our student meeting. I don't know what has happened in recent times where, the pair of Mrs. Henningham and myself having conversations and may have to be calling on students, Mary, Jane, John. No, it is not good. It is really a very sad moment. I don't know when it is that we got to this point. And going forward, I would love to see and hear you guys unmute and participate in class. It's not something that I'm asking, it is something that I'm saying is a requirement, right? It is a requirement. And as I said before, there is a positive correlation with those who are not unmuting and the grades received for the first term. The ones who participate in class and asking their questions and getting their their their, their misconceptions or lack of understanding clarified are the ones who are doing much better. So I'm saying if it is that you want to be in that league, I would encourage you to unmute, speak all if you are understanding. Yes, sir. Yes, miss. We need to know that you're close by your system. It gives us the energy. Trust me, you don't even know. You think money is what it is that we work for in education? We wouldn't be working here, so we're not getting the money. But when we can help a student and the student does pretty well and is able to fulfill his or her dreams, that is a pay that nobody can pay us. So allow us now to enjoy that sort of salary in seeing you guys succeed, please. So start it before the class begins tonight. I'm going to be encouraging and I'm going to congratulate the talkers in the class. I love to hear it. I love to hear it. You guys are doing very well. But when you're not a silent man, you know, sound good. Tati, you have something to say, honey? I see you unmute. Tatiana?
Oh, no, sir, I'm sorry.
Oh, that's all right. That's all right for the munchies. All right. So as we are going to be navigating in class tonight again, I'm going to be encouraging you all to unmute, to be active participants in the class. It's very important. This is how we are able to put a face, we're able to say that you guys are understanding. I toyed with an idea today when I was on campus. I toyed with an idea today. And I know it's going to be difficult for some of you. And I don't want to do it. I'm going to tell you why I don't want to do it, because I don't want to be the person who is going to be responsible for somebody's child being on the road at 9 o'clock at night. But if I'm not getting the participation, I'm going to convert the class to face to face. And I know it's going to be late. I know we did it in first semester. And I want to be able to reach you guys. I think you are comfortable, but maybe too comfortable where you are. But I really want you guys, and I'm going to watch it tonight, and then make a decision. I'm going to watch it tonight and then make a decision. All right. So if Mrs. Walker has her bio class online on a Monday 3 to 5, I don't want to have to say to people who doing bio, you better head out at 5 o'clock in the evening to come to a class for 3 hours. That is kind of counterproductive. So I'm going to ask you students, at any cost, you have to work. Time is against us. All right. Am I clear though? Am I clear? Do we have an understanding? Do we have an agreement?
See.
All right. Thank you. All right. Okay, Miss. I think this is now 13:02. I think we can. You have anything, Miss? To hold on. You know who is that? Okay. Miss D just came on. All right, Mrs. Cunningham, if you want to just go ahead. And guys, we need to hurry tonight. So I mean, I'm gonna ask that you try and absorb the content that Mrs. Cunningham, or you want me to just go through Mrs. Cunningham? What do you want me to do, Mrs. Cunningham? You tell me.
Well, the plan, as I had shared in the WhatsApp, is
Yeah.
to do a quick review, and so that
Mhm.
you can have majority of the time, because I know you're pressed for time and you will need the additional time to catch up
And
and
that's
to
fine.
move the class forward.
And that's fine.
So
Go ahead. Go ahead.
the review, I would focus mostly on one question for them to think back, because what I see happening is that, for example, question 2 on the remainder and factor theorem that we had posed, a lot of persons do part of the question. It's like they keep separating it. Like they're separating, leaving off the constant, and then the answer that they're getting will be different. If they're equating everything to 0, the answer will be different. It is the key between the right and the wrong answer, you know.
Absolutely.
And sometimes if the answer is going to be minus, then they're going to be submitting a positive when it will be incorrect. So things like that you have to pay keen attention to, right? So let's earmark for half an hour, so that you can, half an hour to 45 minutes, so that you can max your time.
Okay, no problem. So you want me to go first,
That's
or you
good.
want me to? No problem. You want me to go first and just do a quick review of what it is?
No, man, I'll do it for you.
You do. Okay, great. All right. So guys,
I'll do it.
Mrs. Henningham is going to go now. So we're going to give about half an hour for the review, and then I will go full-fledged with our continue with our calculus. There's a quick question though. My headspace is not there because I'm teaching 2 different calculus courses at the same time now. Did we start in a piecewise function, or we were just looking at the limit to infinity, positive infinity, negative infinity?
Yes, sir. Just
All right.
that.
Okay,
The
so
latter.
right, the latter. Okay,
Right.
thank you. So what is going to happen tonight, students? I intend to start and finish piecewise functions, and then move into continuity and look at some areas under continuity. All right. So please, I'm going to ask that you give your undivided attention now to Mrs. Cunningham. And when we switch over, you know, you're in that mode to just continue working. All right, Mrs. H, you can go.
Okay, thank you. Okay, students, good afternoon again. And it's going to be an accelerated class, as Mr. Shand has just voiced. So we won't be spending that much time like what we did before on questions. So let me start by sharing my screen. Get this screen up. So this afternoon, we will be doing limits and continuity. However, just as a revision, but to review what we did last week, I'm posing this question: derive the polynomial p of x of degree 3, which has roots equal to 1, 2, and -4. Well, -4. Let's use a correct term, not -4, but it's -4, right? So we're going to quickly think about it, pencil it, pose your solution, and we can discuss, but we're not going to be staying long, okay? Students?
Here, miss.
Miss.
Okay, I was just searching to see if I'm muted still. Okay, guys. So the question is asking you to derive the polynomial. What first comes to mind? Just to get you thinking.
Not sure.
Not sure. Okay. Who recall the when we were starting the remainder and the remainder and the factor theorem one week ago, when we were starting out, we started out using this formula way back in primary school, right? The dividend is equal to the quotient times the divisor, right? The product of the quotient and the divisor, and then we're going to plus any remainder, right? So here, what this is saying is that we have roots of the polynomial given, and I've inserted the definition of what the root of the polynomial is. So the root of a polynomial refer to the values of a variable for which the given polynomial is equal to 0. Does that ring any bell? No? Does that alert you to think of anything when we're equating to 0 using polynomials? No? How about
Yes, miss.
factor theorem? Daniel, what is it saying to you? What does it sound like? Okay.
Miss, I'm going to think about it.
Oh, good. So we have factor theorem, we have remainder theorem. Who remembers what the factor theorem says? So it states that both the factor and the remainder theorem states that if f of x or any polynomial that which is considered as f of x is divided by x minus a, the remainder is f of a, right? And if f of a is equal to 0, then what is a factor of the polynomial?
Zero.
X minus a is a factor of the polynomial. Does right here looks familiar? And when you say root of the polynomial, so here it is saying the polynomial refers to the values of a variable for which the given polynomial is equal to 0. So when you look on the graph, let me not jump the gun, right? It is where you're equating this polynomial to 0, right? Hence, you're getting factors of the polynomial, right? So with this knowledge that you have, this prior knowledge, right? How would you think about it? If they're saying that the question is saying that p of x of degree 3, what is that referring to? Anyone?
P of
Sir
x
ever
equals
mentioned
to 3.
degree 3.
It's called the highest power of x.
The highest power of x, okay. And which has roots, given the definition above and the explanation, given the roots 1, 2, and -4. What do you think these are? What is P of x? Would it be, imagining a graph, would it be the x or the y values in a graph?
Y values.
Right. So if we're saying, based on the definition, that x minus a is a factor of the polynomial, and P of a is equal to 0, or should we say P of x is equal to 0, right? What could be the factors we're referring to here? So we're saying x is equal to 1, x is equal to 2,
2 and 3.
x is equal to -4. What would be the factor here in this question? Where are the gentlemen? No, wait. Not here as yet. John Mark. Yes. Go
Would
ahead.
be 1 minus a. I don't know what's a. So
1 minus a.
Miss x minus 1, x minus 2, and x plus 4.
Nice. So, Aniki, I see why you would say 1 minus a. Based on you putting x to be in the bracket here in the linear function, x minus a. However, the answer I'm looking for is as stated by, can you repeat it for me, please?
X minus 1, x minus 2, and x plus 4.
X plus 4. So would you be able to find the polynomial of P of x of degree 3? How would you work that out? So you have the answer. Remember the long division, the synthetic division. We have the quotient. We have the divisor. We have the remainder. But in this case, it's a factor, so we don't have a remainder. Henry, do you have something to say?
no, miss.
Okay. I think you can. I think you can. So the introductory activity is going to be for your homework because we need to move on, right? We'll need to remind ourselves as to the limits because sir will be moving full speed ahead to catch up on what he missed last week, right? And this time around. So any other idea before I move on? John Mark, I have to give the soft spots to the gentleman.
What was that, miss?
Do you have any ideas to how to derive the polynomial? And who was it that said that to the highest degree of 3?
Sir Miss Shanti.
Nice, Shanti. And we also had additional information here. So you said the factors are Tennille, you gave me this factor?
Yes, miss.
Right. And what is the second one? X minus 2. And the third, why did you say x plus a?
X plus 4. It's
Plus 4.
because it's x minus a, and then when you put in the minus 4, it's minus minus, which is plus.
Okay, everyone with us on that one?
Yes, miss.
Yes,
All
miss.
right. So we have the factors. John Mark,
Yes, miss.
what idea comes to mind? I just, when you deal with and you grow up with a lot of males, you get to find out that their perspective is just totally different. So John Mark, you're given 3 factors. So the group has reached this far, 3 factors. Would you be able to work this out to find the polynomial with the highest degree of 3?
Miss, I'm not sure. I'm not sure.
Try. You're not sure. Let's try. What first comes to mind? I think somebody's thinking about it, However, probably you just don't trust what you're thinking about. So let's continue to see if this will ring a bell. And we're moving on.
Miss, you mean to get
Because
a remainder of 0? Is that what you're talking about?
we already have said that the question says that this has roots equal to, and based on the definition given here, it says roots of a polynomial refer to the values of a variable for which the given polynomial is equal to 0, right? And it
Yes.
continues, if a is the root of the polynomial p of x, then p of a is equal to 0. Does that sound like any of the theorems we have dealt with, the factor and the remainder theorem? It also goes on to say that x minus a is a factor of the polynomial. That's what it means. Does it sound like anything, any connection there? We just did remainder and the factor theorem. The remainder and the factor theorem, does that sound familiar to you?
It sounds familiar.
Oh,
Yes.
okay. So here we go, John Mark. We're building it together. 3 factors. Would you be able to derive the polynomial given these 3 factors?
Yes, miss.
That's what the question is asking.
Yes, miss.
So Tadila, just getting it, you have to say the yes twice, right? Just getting it.
Yeah.
Anyone else is seeing it, having the revelation as to what to do? John Mark is still thinking about it.
Yes, miss, I'm still trying to see it.
You're trying to see it. Anyone else?
Yes, miss.
What is that? Yes, no, Shanti. You're
Yes,
seeing what to
see
do?
it. Yes.
Okay. Anyone else? I just want to know if I can see what to do, to find the polynomial p of x. Repeat, unmute again.
Miss, I just came on because the Wi-Fi is acting up.
Okay, Javia, we're just starting and we're moving a bit at a faster pace this evening. So the question is, Javia, derive the polynomial p of x of degree 3, which has roots equal to 1, 2, and minus 4. And the definition is given there. So if you can take a quick snip.
Okay, Miss, I took a screenshot.
Nice. All right. So this is where our classmates have brought us to in the question. So we have 3 factors. And the question is, would you be able to derive the polynomial given the factors of the polynomial? And the question, Javia, you would be able to do it?
No, miss.
No, miss. Okay. So Shante and Tanil, anybody else? Can you share the idea that you have come up with? One of you, I think it's 3 persons that said that they're seeing it now. Just share your idea. Let the class hear what you're supposed to do. Then we're moving on. You can take a snip and we'll look at it. You can send in the group the response and I'll share with you. What's your idea? What is it that you said that
You
you're
said no,
going to do?
miss.
Come on, say it now.
Oh, miss, they could have done the FOIL method. So you multiply x minus 1 by x minus 2 first, and then you multiply, and whatever you get, you'd multiply that by x plus 1.
Everybody hears that? Have you heard that?
Yes, miss.
Any clearer or mud?
You can repeat it, please. Can you?
Come Tanil, go again.
I was saying you could use the FOIL method with the 2. You could say, you'd multiply the x by the x, then the x by the minus 2, then the minus 1 by x, and then the minus 1 by minus 2. And then that will give you a trinomial, and then you would multiply that by the x plus 4. So you use FOIL method for the first, for x minus 1 and x minus 2, and then you would multiply that by x plus 4.
Is there anyone unclear as to what to do? Okay. So the method used by suggested x times x gives you
X squared.
right, and then x squared, then you have x right, and then what's the next one?
X times negative 2, which is minus 2x.
Are you seeing, is everyone seeing that, guys? So can you continue and complete the question?
Yes, yes.
This is a practice session, you know, so you have to, if you're not seeing it, say you're not seeing it, right? So x times x give you x squared, x times minus 2, negative 2 gives you negative 2x, 1 times x gives you minus 1 times x, gives you minus 1, or negative x, sorry, use the correct term. And you continue, okay? Tanish Hitchman, is everything okay?
Yes.
Okay, so that will be your challenge to continue. I know you can do it, so I'll not go further on this question. Just try the method as discussed, and then you can share with us the answer, okay? Let's remind you of the limits. The sir will be continuing with calculus, right? Or is it that you do want 5 minutes just to go through the question and we can discuss? Speak now or forever hold your peace. Because I'm hearing the hesitance here. Green, go ahead.
Let's go through the question.
Go through the question. Okay. Cassiana, Henry.
Yes, miss.
No, sir. You couldn't even let the class move on. Let me see who else. Very good, Cassiana. Cassana. No, it's Cassiana. Right. Very, very good. Daniel. Guys. No, man. Come, Henry. What did you do? I'll write for you. Come, Henry. I'm
First,
proud of you.
the x minus 1 and the x minus 2, and I got x squared minus 3x plus 2, and then I multiplied that
Look, hold on, Henry. See where I've reached typing? What's next? What's after this?
plus 2, and then you multiply that by x plus 4, then it, so that would be x squared minus 3x plus 2 multiplied by x plus 4.
Who is going to reward Henry for her efforts now? Eh? And the other persons who have submitted their answer. That's very good. Is that it?
Miss, and then it gets x cubed plus 4x squared minus 3x squared minus,
Miss, you're going too fast.
sorry, x cubed plus 4x squared.
X cubed. So how did you get x cubed? X squared times x, right?
Yes.
And then you say what?
X squared times 4, and I got 4x squared. Then minus 3x times x, and I get minus 3x squared.
Minus 3x. No, sir. This is too much. This is too much. But I am glad 3x squared, right?
Yes, miss.
I am glad that you stepped out and that you have identified that you've got it. And guys, are you seeing it? Are you understanding so far what Henry is doing?
Yes, miss.
Right? Who is not understanding? All right, Henry. Green, is it that you're able to speak? Henry is willing to assist you. Come. Where are you now?
Repeat, miss.
What, where in the solution you are not understanding? Where did we lose you?
Beginning.
All right, where? I'm scrolling up. Tell me where I reach. Where?
2x.
Right here?
Yes. Yes, miss.
Okay. Henry,
Yes, miss.
why is it? Can you explain to Green what is happening right here? Right here. So Green, did you, I mean, do you understand the factors, how we came by the factors? Speak up, Green.
Not really.
Not really. Chante, how did we come by the factors?
Miss, repeat, please.
How did we come by the factors? These here, x minus 1, x minus 2, x plus 4. How did we come by the factors? All right, so we got the factors from the question, right? Based on the question, it says derive the polynomial p of x of degree 3, saying that the highest degree in the question, right, is 3, right? And we gave this definition to say the roots of a polynomial refers to the values of a variable for which the given polynomial is equal to 0, right? And the additional information equates p of a equals to 0. So the connection I wanted you to make, Green, is that when x minus a is a factor of the polynomial, this sounds, it gives a good connection to the remainder and the factor theorem that we're doing, right? So when the roots is when the p of a is equal to 0. That means when it is 1, it is x minus 1. We're equating it to 0. So that's how we got the x values to be 1. So when we say x minus 1 equals to 0, what is the value of x here? Green, what is the value of x here? Green? What is the value of x here?
-1.
Negative, try again. So we are saying x minus 1 is equal to 0, right? That's what we're saying. X minus 1 equal to 0. That means x is equal to 1. So we're removing the 1 from the left-hand side by plussing 1. And we're doing the same thing on the other side by plussing 1. Right? So that would leave us with x equals to 1. So that would be the values of x in the polynomials, the values of x when you're talking about the roots, right? So it's 0 and 1. 1 here, the x value is 1, the other x value is 3, is 2, and the other x value is minus 4. But in order for you to get the x values here, they're coming from here, the factors. Okay? You're seeing that, Green?
Yes, miss.
Right. And we do that for all 3 of them. And when we get the 3 factors now, what we do, does this format looks for me? This format looks familiar to you? When we're doing factor theorem, we always end up with 3 values, right? 3 possible values for x. And someone says that we need to do the foiling method so that we can expand, right, these factors to see what it will give, what the original, right, trinomial is. Okay, Green? So are you okay now to hear? Green?
Yes, miss.
You're okay now?
Yes, miss.
All right, good. Okay, you can complete for me, please. Henry?
Yes, miss.
So we are at 3x squared. What's the
And
next?
negative 3x times 4 gives you negative 12x. And 2 times x give you 2x.
Is that plus 2x?
Yes, miss.
And
And
then
then plus 8.
plus 8. And what are we doing now? John Mark, what are we doing now?
Grouping, miss.
What are we doing now? What's the next step to here?
Miss, you're gonna group the like terms.
Group the like terms. And what is the answer now, Henry?
X cubed plus x squared
Mm-hmm.
minus 10x plus 8.
Mm-hmm. Plus 8. Everyone seen that?
Yes,
Good
miss.
effort.
Yes, miss.
Good effort. Good effort. Very good. All right. So please write that down. I am going to move on and save the typing a little. Right? So grouping like terms. So we did the limits and sir is waiting. So I'm going to ask you to just let us read the definition and we're going to do one question. One question to remind us of limits. That is what sir is continuing today to move on for calculus. So if the value of f of x approach some value of a limit, L as the values of x approach a from both sides, but it's not going to be equal to a. X is not going to be equal to a. Then we say the limit of f of x as x approaches a is equal to L and we denote this as, that is the notation there, right? So we are going to evaluate. We have a lot of practice questions. So if you want to take a picture of these practice questions, we can always do it and I'll share with you the response afterwards. So I have 5 questions on the screen and we're going to be doing one of them. So everybody take a picture of the screen. So we're getting in the practice so that these little errors that we're making where we flip the sign and, oh, I didn't realize it's a negative sign, and this we can, with practice, we can, control those little errors. All right, so that is 1 to 3, 4, and 5. We're doing question 5. Can somebody read this question for me?
Which one, miss?
Question 5. Read the question
When
for me, please.
the limit of x tends to infinity is 4x squared minus 5x over 1 minus 2x squared.
Thank you. Can someone else, just by using sight, tell me what the answer will be?
Miss 4 over 3.
4 over? Let me
3.
see who's speaking. 4 over 3. The participants, I cannot see who is speaking. Can you say who it is?
Miss Xavier.
Javia. Thank you for attempting. Does anyone else has a response?
Miss
Something
negative
different?
4 over 3.
Negative 4
Same
over
thing.
3. What is same thing? That sounds like Taniel. What is same thing? 4 over 3 or negative 4 over 3?
4 over 3.
4 over 3. Okay. Thank you for that feedback. Anyone else? John Mark. I can't see if Matthew is here. John Mark,
Yes,
what is the answer for this one using side? Just by looking at it. And you're
4 over
evaluating the limit. 4 over?
3. 4 over
4 over
negative 3.
3.
Over
Over
neg yeah,
which
over
one is it?
over 3.
Which don't say the answer no. Which one is it?
4 over 3.
4 over 3. That's your final answer.
Yes, miss.
Somebody else. I remember Parker online. Monish, is it Monisha? I cannot see the participants now. Is it Parker? Are you able to see the answer to this question? What
Miss,
say you?
4 over 3 for our negative 4 over 3. See that one I
Which,
did?
no, it's one answer, it can be, not two. One.
Me.
So which one is it? Parker?
4, negative 4 over 3.
Okay. Anyone else? By side? Mr. Shand, your turn. What is the answer to this question? Number 5. Where's Mr. Shand? This is the handover cue to Mr. Shand. Okay, we'll continue class. So the response, the one more. Who else? Natalia Buckley. What is the using sight? What is the response? What is the answer to this question? So x tends to infinity is equal to? Is Natalia with us? Okay. Repeat that, please.
Miss.
What? Go ahead. Go ahead, Javier.
Miss was saying 4 over negative 3.
Okay. Thank you for
Miss,
that
can I
response.
change my answer?
That is fine. That is fine. Anyone not seeing the answer? Is there anyone not seeing the answer? So everybody is okay. Cause Green, are you seeing the answer?
No, miss.
Panil, this is your opportunity to redeem yourself.
Oh, Miss, I was saying 4 over negative 2.
So redeem yourself. Green is having a little challenge. Can you explain to Green what you did to get that answer?
Okay, Miss. So the x that contains the highest power is x squared. So you're going to divide everything in the numerator and the denominator by x squared. Wait, Miss.
Okay, I'm just repeating what you're saying. I'm not picking up, I'm not finishing it off for you,
Oh,
Tanil.
Miss, I didn't do
Right?
something properly. So I'm going to change my answer again to 4 over minus 3. So you're going to divide everything by x squared in the numerator and the denominator. So when you divide 4x squared by x squared, you're going to leave out with 4. And then when you divide minus 5x over x squared, you're going to get minus 5 over x. And then it's going to be 1 over x squared minus 3 because the x squares are going to cancel each other. So as the limit tends to negative
Infinity.
to infinity, minus 5 over x and 1 over x squared are going to all go to 0. So you're going to have 4 minus 0 over 4 minus 0 over 0 minus 3, which is going to give you 4 over minus 3, which is negative 4 over 3 or 4 over minus 3.
Nice. Green, do you still have a question on that explanation? Anyone else? So calling Mr. Shand, I think your class is prepped and ready for you to continue. So guys, have you taken the picture of the other questions? You
Yes.
can share, do the questions. That's what we were about to evaluate. Do the questions and share your response. You can do it in the, share your response in the chat or otherwise. Nice, Donaldson. Very good. So remember, I'm here to facilitate you getting additional practice, okay?
Miss, sorry, supposed
I came off there. Repeat that, please.
Miss, I'm supposed to send the answers to these in the chat right now.
You can.
Miss, can I see number 4 and 5, please?
Sure. So John Mark, you're comfortable now with the polynomial P of X. Shante, correct. John Mark,
Yes, Miss.
okay, good. So where is Matthew? Has anyone heard from Matthew? Chanel, is everything okay?
Miss, I just came in, so haven't started.
Okay. Okay, so what you do, Chanel, is that I'll take pictures of the questions. You can work it and send it to me in the chat. I'll confirm or guide you as to where you're going wrong, right? This is for number 4 and 5. And up here we have 1 to 3. So it's questions 1 to 5 we're doing, right? So we are really awaiting Mr. Shang, right? Take a picture. I'm going to show you the introductory activity, which is a review of the factor and the remainder. We're just making a connection to that theorem. So scrolling up, not yet finished working out. Henry was assisting. Must I have it worked out? So it's derive the polynomial P of X of degree 3, right? It's saying the highest power or exponent in the polynomial, which is 3, which has roots equal to 1, 2, and minus 4. And from that information, we deduce that x, when x is 1, the factor is x minus 1, right? And sharing with you the definition which was introduced. We made a connection with that of the factor theorem. So we're saying then if P of A is equal to 0, x minus A is a factor. And with that connection now, we were able to find the polynomial P of X. So guys, listen, not even if you have K of X, T of X, still polynomial, still function, right? Let me see the responses. Question 4. Try again. Tati. Good job, Shanti. Donaldson, nice. Not, this is, try again. Try again, Natalie. We got a value. We got a value. We did not get undefined for number 4. Henry. So Henry, for your number 2 and 3, good job. Look at the class working in silent. This is nice. Where is Mr. Shand? Is everything okay? Let me give him a call if everything is okay.
I'm fine. I'm right here. So you're calling me?
Yes, we were calling you from hours ago.
No, man, I heard, I heard it call me, and then after that, then I heard it talking, continue talking. So I said, okay, fine. No, man, I'm here, man.
Right,
I'm
because
here.
we were extending the conversation until you come because we have worked our example.
Yeah,
And
man,
I'm still getting feedback in the chat.
in the chat,
Before
yeah.
you, yes, before you go, Tatiana, which question is the last answer for? Okay, I'm asking someone to volunteer to work out number 4 for me, please. Let's go back to number 4. Come on, guys, start waiting, ready. Number 4. Unmute, please. Somebody unmute. So now everybody just chatting in the chat. Can someone unmute and work out number 4, please? Last call. Tati, difference. Yes, yes, Tanil, that is it. Henry, yes, work out number 4 for me, please. Kessiana, let's, yes? Okay, Tati. Kessiana Henry is going to assist us with number 4. Henry?
Yes,
Just
miss.
describe what did you do, what the process you did to get your derive your answer.
Okay, miss, since I said the denominator result to 0, I factorized the numerator, I got x plus 4 and x minus 4. I cancel out the x minus 4 from the numerator and from the denominator, then I left with x plus 4, and I sub the 4 for x, and I got 8. Or the, yes, that's it.
One. Sure, Tati. One question though, Henry, you are saying the first thing you said was you get 0. How did you get the 0?
Miss, I noticed that if you sub for the 4 for the denominator, you get 0 for the denominator. So I have to
But
find,
if I put 4 in the numerator too, I get 4. I get 0 as well. Just by substituting it. So
yes, but I
why
noticed
changing the method?
first.
Repeat that.
Just because I noticed the denominator first.
Oh, you notice the denominator first. Okay, so if I say 4, all right, difference of 2 squares. Patty, difference of 2 squares, completing the squares. Okay, I see what you're saying. So if I say x squared minus 16, right? This would be x plus 4, x, let me type it up for you. X, take off this. But what I'll do, I'll send you the answer so you don't have to worry about it, okay? And yes, what I'll do is to ensure that the responses are typed up so that you can get the response. Right, so it's x squared. So that the numerator will work out to be x minus 4 and x plus 4. And all of this will be divided by the x minus 4. So that's all you're left with, x plus 4, right? And the x plus 4, when you substitute the x into the equation of 4, so it's 4 plus 4 giving you 8. All right, so I'm going to type it up and send you the response. Let me see if this is a document with the response below. Right, I just have the x equals 8. So we're left with x plus 4 and it's equal to 8. Okay, Tati? Tati? That, okay, nice. All right, Mr. Shand?
Miss, can I see number 4, please? For up at the top.
Number 4.
You said x plus 4 and x minus 4. That's for the x squared minus 16. You broke it up and said x plus 4 and x minus 4.
Not x plus 1, x plus 4 times x minus
4.
4.
Okay.
What is that called?
Difference of 2.
Okay. Difference of 2 squares. Right, sir? Your time. Stop sharing. Guys, I'll send this to you. I'll type it up in a more expounded way so that you can get the answers, okay?
Okay, Miss,
Guys,
thank you.
Yes, you're
Thank
welcome.
you, Miss.
You're welcome.
All right, so thank you, Miss. I'm going to ask you to do me a favor, guys. So I came to the class also with some questions on limits. This was supposed to be an exercise for you to do in class today, but because Miss went through that exercise with you, I'm going to ask you to screenshot this one, please. Do a screenshot of your device or take a pic. Capture these questions for me. These are going to be activities to be answered on Friday, God's willing. And guess what? you don't know who I'll be calling upon for the solution. So I won't come to class and say, who did the question? I'll say, Jane, 4A, Mary, 4B. All right, so these are some questions as practice. Remember, we don't have much time, so we really can't be overkilling a topic when I have others to look at. So those are questions that I want you to look at for me. So let me know when you have screenshotted those, so I can move into some other areas. Let me know, please, guys, so that I can move on. I don't want anybody to be writing them off, and I don't have the time for you to write off. I want you to screenshot it.
Have it already, sir.
All right, thank you.
Yes, sir.
Can I remove the screen? Is there anybody that is still picturizing it? All right, I'm removing. Okay, so we're on to continuity. The aim is to go through continuity tonight, as also to look at some piecewise functions. I did this with a group of students on Saturday morning, and some students who are, I don't consider them as advanced as you guys are, and they got it. Now I'm going to see how well you guys will get it. They got it, one shot, and they got it. So let us see how well you guys are doing it. All right. So I didn't hear Miss ask for the one sentence prior to the. So let me just offer it as we are about to begin this year or new topic. So Lord, as we are about to begin, I pray that you make us increase their mental capacities, grant them added wisdom, knowledge, and understanding as we move forward. In Jesus' name, we pray. Amen. That's like about 3 or 4 sentences, but never mind. I learned to count one of these days. So we're going to talk about statements, condition for continuity. Conditions for continuity. Now, a possible multiple choice question would be, which of the following are conditions for continuity? And they will give you 1, 2, 3, 4 stuff. They will say 1 and 2 only, 1, 2, and 3, all of the above, whatever the situation is. All right, you need to know the conditions for continuity. Now, let me just walk you through the conditions for continuity. So f of a must exist. F of a must exist. All right, you must have a function that when you are substituting a value into the function, it exists. If you can't substitute a value into the function, it means that already the conditions for continuity would have failed. So the f of a must exist. And then the second condition is that the limit as x tends to a to the left must be equals to the limit as x tends to a to the right. The limit as x tends to a to the left. Sir, what do you mean by a to the left? Remember when we were doing limits, I spoke about the intuitive method.
Yes, sir.
Yes, sir.
Right. So we talk about the left-hand side and the right-hand side. I don't know why this is like this. Let me just fix it. Yeah. We spoke about the left-hand side and the right-hand side. This is to the left. So to the left, we did not know. So you see what I'm doing now? I'm building on the information. So instead of writing LHS for left-hand side and RHS for right-hand side, we're going to put a superscript, not sub, but superscript negative sign to represent the left and a superscript positive sign to represent the right. Now remember, I said to you negative. Left is representing negative support and so on, and right is representing that. When you are moving to the positive side, you move to the right-hand side. And when you're moving to the negative side, you move to the left-hand side. when you look at your number line technically, right? The same concept exists. So that was the intuitive approach. Now, when I go down to my conditions for continuity, is the same thing. This one is the right because it's a superscript plus. Plus is right, negative is minus. So just as how we are looking at the intuitive approach, and I said to you, in order for it to be of a good behavior, what happens on the left-hand side must be equal to what happens on the right-hand side at the same something you're talking about. So I'm now going to be developing the argument that we've started some weeks ago. All right. So I'm looking now at the limit as x tends to a to the right. It's supposed to be equal to the limit as x tends to a to the left, which technically is going to be equal to the limit as f of x, as x tends to a of f of x, and that must exist. All right. What I'm saying to you is that when you're finding the limit of a function, you have to investigate to the left-hand side first, and you have to investigate to the right-hand side. You can't just go ahead and just substitute a value into the limit. You have to investigate what happens to the left. You have to investigate what happens to the right. And it's not the first time you hear me say this. And if both left-hand side and right-hand side coincide, then you conclude that the limit is of a good behavior and that the limit exists. That's exactly what this line here is saying, line B. And then line C knows that f of a is going to be equal to the limit as the x tends to a of f of x. So this must exist, then this will hold through, and then this piece up here so is going to be equal to this piece. And these are the three conditions for continuity. You study it further when I go into more of this, and then I'll come back again at the conditions for continuity, and then you see exactly what happens. Normally, I go through the areas first before I give it a definition, but this time I decided to give it a definition first. So some of you may not even understand fully what the definition is talking about until you see me work one or two of the questions, and then we move on from there. Now, what I'm going to do here, I'm going to animate something here. Be patient with me. I'm going to animate something here. But I just like this. All right, I'm going to animate something here. Watch me. If I go like this without lifting, am I able to do a continuous curve? Yes or no?
Yes.
Yes, sir.
Okay. But if I'm doing like this and then my pencil just the pen not writing so good, and every time I go, it ease up a little bit and it not writing. Is that a continuous curve?
No, sir.
No, sir.
All right. So right here so, and here so, and here so will be called points of discontinuity. Points of discontinuity. So here is a discontinuous function. Here is a continuous function. C versus D. So I'm going to talk about some things here now that you need to know. So a continuous function is where you can use a pencil or a pen and draw a curve without lifting the implement. We say that that function is continuous. If the function, on the other hand, is discontinuous, it means that when you are drawing your curve, at some point in time, you are lifting the implement from the page, putting a break into it. It means that the function is discontinuous at those points, at that point or those points. All right? So that's all that there is to it for you to know the difference between continuity and discontinuity. When a function is continuous, you can draw it one shot. When it's discontinuous, there are breaks in the graph. Just think of it like that. Now, let us look at this quick example. I'm not going to do many of these because we need to move. It says find the value of x for which f of x, which is equals to 1 over x squared plus 9x plus 20 is discontinuous. And another word that I'm using for discontinuous is undefined. Undefined. When does a function become undefined again? Anybody, somebody? When does a function become undefined? When the what?
When the denominator is equal to 0.
The denominator contains a 0.
Yeah. I wish man unmute and answer a while ago. John Mark, was that you?
No, sir.
Charik, that was you?
I mean, man, sir. I mean.
John Mark, you know, they want too big lick, you know, if I can be working a boy. You just get very lethargic at times. But very good. No, sir, my youth, you can buy a beer. Sorry, I can buy a soda.
Beer, sir.
No, but you all right, very good, John Mark. Very good, guys. All right. So this is why I'm not going to be doing a whole lot of this tonight because I know you guys know it. I have done this with you before. I'm going to tell you something about beer, you know, and this is just to lighten the class. I remember I was in high school, little boy, and you know, used to fly up every Christmas and summer to visit family and friends, yeah, mainly family. And I remember when I got my driver's license, I used to love to drive. And the moment I catch my driver's license, then buy a car and give me and say, you are going to be babysitting. And when they want to go to Chuck E. Cheese and they want to go anywhere, you will drive them around. So me glad because me to get license, me want go in a car and drive. Anyhow, one day in question, my aunt said to me, oh, I'm going up the road. So I said, okay, good. And I was heading over to the passengers. She said, look, when you're here, I don't drive. So I said, not a problem. It's really not a problem. And I remember reversing the car out almost about 100 lanes. I have to reverse in the middle lane. And I did that perfectly. And I drove to one of our friends' house. I said, remember him? I said, oh, the little boy. I said, who you for little? She said, well, he's driving there, you know. She said, oh, would you like soda or beer? So I said, but they can't be big boy when you go give me soda. I said, beer. And she took out a red stripe light. Lite, that one. And I drank it like water. And she passed me. I said, wow, would you like another one? And me said, idiot, me said yes. And I drank the other one again. Class, if you want to tell anybody this, I will deny it. All when the recording is there, I'll deny it. I couldn't see straight. My idea must spin. The place a spin. I feel dizzy. I start sweat. And I just went to my aunt and said, I am ready. She said, come on, drive. I said, nope, no driving. And I went home and the red stripe light, the 2 bottles of red stripe light, gave me about 12 hours sleep. What's the moral of the story? We're not supposed to drink. Our bodies.
Sir, you're not supposed to drink.
Exactly.
You know, you see what I mean? Every night I'm recognizing more and more you're not on my side. No, but seriously, guys, my vision was impaired. My functionalities was, I mean, I'm saying to myself, how people drink them something there, right?
Sir, your head light.
I'm need to tell you, my head is LITE. If me I eat piece of rum cake in a Christmas, it will drunk me. Me not lie you. Can't do it. There, I mean, I can tell you one of the ways that I will not die is by cirrhosis of the liver because I know I can't drink. I want to, some other time I'll tell you how the Smirnoff ice gave me about 24 hours sleep here. That's another time. Not another story for another time. But the moral is, including you, Tanil, please guys, don't drink. And especially if you're driving, don't drink and drive. All right, let's go. So, yes, Mr. John Mark, don't get a bottle of Pepsi. So when we're looking at a function, remember that there is going to be a point of discontinuity when the denominator is equal to 0. So whenever we get a question like this, all we're going to do is set the denominator equals to 0. Solve it for the value or the values of x. Now, Miss asked a question earlier, and I thought she was going somewhere with the question, but I thought she was going somewhere that I was going. My headspace went somewhere, but her headspace went to a different avenue, right? And it's a correct avenue, you know. It's just that me the want the journey go a little longer, but she decided that, you know, the journey in right or so. But me did like the scenic view, and she asked a question about the degree of the polynomial. And I mean, the answers that the responses that we got were correct. She spoke about the degree of the polynomial. Now, when Miss was doing that, I was going to extend, well, I extended the question in my headspace. And here how me going to answer the question here now, but I'm gonna go back to what Miss asked earlier. Miss gave a polynomial with of degree 3 x cubed. How many answers are you expecting there?
3.
Why?
3.
Why?
Because the degree is 3, so the most that it's supposed to have is 3.
Very good. So the degree is indicative of the number of solutions that you have for the question. I'm very happy that you remember that. I'm very happy that you remember that. So if I give you a polynomial of degree 4 and ask you to solve, best believe that I'm going to have 4 solutions. So therefore, if I give you a polynomial, which is really a binomial or a quadratic, you know, right? So a polynomial x squared plus 9x plus 20, how many sets of values or values do you expect here?
2.
2, because the degree is
2.
2 every single time. So when you look at the degree of the degree of the polynomial is the highest power to which the polynomial is raised. And guess what? It don't have to be the first term that the polynomial is raised to. It could be just like when we read the limits, then can mix up the something. All right? So the degree tells you how many answers. So in this particular case, I can look at it to say that there are 2 points of discontinuity. I can say to you that there are 2 points of discontinuity. Now, I'm sure some of you would have done this while I was telling my corny story about me and drinking 2 Red Light and getting drunk, very drunk at that too. I want you to find for me the values of x. And instead I tell you values because I know it's more than one. I want to find the values of x that makes this function f of x undefined or discontinuous. Let me see if you remember how to do it. It's an activity. What you're going to be doing is setting your denominator equals to 0 and solving. You're setting your denominator equals to 0 and solving. So what you're doing, you're going to be saying x squared plus 9x plus 20 is equal to 0. And I heard by Mrs. Henningham was teaching, somebody correctly say you're multiplying the coefficient of x squared by the constant and you are trying to find that, and it's the same thing that you're doing. So I'm giving you 2 minutes to have that done and tell me the values of x, please.
Okay.
Sir?
Yes, hon.
Sir, I got x is equal to -5 and x is equal to -4.
Bueno. All right, very good. Sorry, very good. Now, yes. So the solution is, now let me just run through the solution with you. Very good, Tantan. And I really hope that the rest of you will follow suit. But let me just refresh your memories. We have done this multiple times before in this very course. This is just going to be a refresher and a very quick one at that. Now, what we're going to be doing, the solution is, the function is undefined when the denominator is equal to 0 every single time, barring none. Every single time when the denominator is equal to 0, you're going to have a function that is undefined. All right? So therefore, you're going to set x squared plus 9x plus 20 to be equal to 0. This, the denominator, you're setting equal to 0. So we're going to factorize to obtain the value of the values of the unknown. And we see that the factors are going to be 5 and 4. Sir, how do you say that? I'm multiplying the coefficient of x squared, which is 1, by the constant, which is 20. And I'm saying to myself, I need two numbers. When multiplied together will give me 20, but when added will give me 9. And only two dege number in the number system that when you multiply together will give you 20, and when you add will give you 9. And those two dege numbers are 5 and 4. 5 times 4 is 20, but 5 plus 4 is 9. So those are my factors. So I'm breaking up my middle number, 9, into 5x and 4x. I color coded it so it is that you can see what I'm talking about. All right? So this 9x here is being broken up into 5x and 4x. So you're going to put 7 and 2 because 7 plus 2 is 9. I agree. But when you multiply 7 by 2, you don't get 20. All right? So it has to fit both conditions, the product and the sum. So now that I've broken up my 9x into 5x and 4x, I'm going to be grouping. When I group, I'm putting the first two in one bracket and the last two in another bracket. But sir, when I did the question, I put x squared plus 4x plus 5x plus 20. It does not matter because addition is commutative. 1 plus 2 is 3 and 2 plus 1 is 3. It doesn't matter how you add, it doesn't matter how you multiply. So addition and multiplication are both commutative. Division and subtraction aren't. All right? So if you decided to put the 5x before or the 5x after, it really doesn't matter. Trust me on that. All right? Now, because this is a positive sign, I'm going to leave out the sign and I'm not going to change anything. When the question is a negative sign, yeah, we have to flip. And I did say that to you. So now that we break up two things in one bracket and leave out the middle sign every single time and the other two things in another bracket, I'm going to be asking myself this question. Hear the question. Don't blink. What is common here that is common here? And your answer should be x. Hear my other question. What is left when I take out one x from here? Your answer should be x. What is left when I take out an x from the 5x? The answer should be 5. Then I'm going to ask myself the question here and here again. What is common? And I recognize 4 is a factor of itself. Why, sir? Because 4 goes into 4 exactly. Or when I divide 4 by 4, my remainder is going to be 0. So you see, it comes back to the factor theorem, the factor and remainder theorem, right? And our polynomial division. So when I divide 4 into 4, it goes into it exactly. So that's another way you can say it. Or when I divide 4 into 4, it leaves a remainder 0. So 4 is a factor of itself. So is a factor of 20. So when I subtract, when I'm looking to see what is common, I'm taking 4 from both. What is left when I take 4 from 4x? It's going to be x. What is left when I take 4 from 20? It's going to be 5. For ease of visibility, I color coded it. What is common here? That is common there, and you can see the x plus 5. So I'm taking it out. What is left is going to be x plus 4. Those are not the answers. What we're going to say now is either x plus 4, the piece here, equals 0, or x plus 5 is equal to 0. And then it's going to give me my x equals 4, negative 4, or my x equals negative 5. And if I want to prove it, look, my function, let me just copy this for ease of this computer, Jesus. The whole weekend, it nearly made me speak in tongues. Jesus. All right, so. So what is happening here now? So this is my original question, and I'm double checking my answer by substituting my negative 4 into the function. So anywhere in the function I see x, I'm putting negative 4. So f of negative 4 f of negative 4 is really going to be now equals to 1 over negative 4 squares plus 9 times negative 4 plus 20. And it works out to be negative 4 squares is going to be positive 16. Aha. When I raise a negative number to an even power, my result is positive. I want you to remember that, you know. When I raise a negative number to an even power, my result is positive every single time. When I raise a negative number to an odd power, my result is negative every single time. So it's very important for you to recognize and remember those little shortcuts in mathematics, all right? And then 9 times negative 4, 9 times negative 4 is going to be equals to negative 36. And of course, I have my positive 20 now. 16 minus 36 is negative 20. And negative 20 plus 20 is going to be equal to 0. Now, you see the fraction here? 1 over 0? It can't work. Can't work. There's no way it can work. All right? Undefined. And similarly, when I do that, I'm going to get the same things undefined. All right? So that cannot work. I'm going to send those as examples for you to do, but I need to give you one with a negative sign to see how well you work at it. So I'm going to give you this one. After this, we're moving into a piecewise. Can I give you 3 minutes? Beginning now?
Yes, sir.
Has anyone gotten an answer?
Sir,
Yes.
Don't finish, sir.
All right, 1 more minute.
sir, check the chat.
Will do. All right, let's go. So my solution here is going to be, again, the function is undefined when the denominator is equal to 0 every single time. So I'm going to have x squared plus 5x minus 6. So to factorize, we're going to factorize to find the value or the values of x. I'm going to set the denominator equals to 0. In setting the denominator equals to 0, I'm going to have x squared plus 6x minus x equals 0 because I've already found my factor. So let me just put in my upper line so that you can see what I'm talking about here. Just 5 equals 0. So I'm setting equals to 0 first. Then I'm breaking up. How do I break up? I need to multiply the coefficient of x squared. The coefficient of x squared is a number in front of x squared. So I'm not seeing a number in front of x squared. Look again, because I'm seeing a 1 there. So is Mrs. Cunningham. So I want you to be able to see the 1 in front of the x squared. Sir, x is equals to 1. That's why I don't. No, x is a variable, and the root word of variable is vary. And when something varies, it means that it don't have one something. It takes many different somethings. So therefore, x cannot be equals to 1. That's a common error for students who are taking exams, calling x to be equals to 1. So the variable is the coefficient is going to be 1, the number in front of x squared, not the value of x squared, the number in front of x squared. I am multiplying that. Yes, please.
So we get 6x from and negative x.
Then I reach yet. That's where I'm going now. So hold up. So the method now is to multiply the coefficient of x squared by the constant. I'm multiplying the coefficient of x squared by the constant. The coefficient of x squared is 1. The constant is -6. When I multiply 1 by -6, I'm going to get -6. I need two numbers. When multiplied together gives -6, but when added will give me a +5. I need two numbers. When multiplied together will give me -6, but when added will give me a +5. Now, the factors of -6 would be, could it be -3 and -2? Question.
Yes, sir. But you wouldn't get a +5.
That means it could be. Because if I want the factors to be -6, I couldn't have -3 and -2. Because when I multiply -3 by -2, I'm going to get a +6. So -3, -2 is a non-answer. And if any of you have it there, etch it somewhere on your forehead. This factorization is one that is often given by TXC because a lot of students make that error by using -3, -2 as opposed to -1 and +6. The other one will be 1 and 6. The other will be 1 and 6. So two sets of numbers when multiplied together will give me 6, will be 3 and 2, and 6 and 1. Those are the only two numbers that when multiplied together, that will give me 6, 3 and 2, and 1 and 6. However, one of them must be negative and one of them must be positive. Because I want a +5, I want a +5. The only pair of values I could use would be the 6 and 1. 3 and 2 can't give me at all because I want a -6. In order for me to get 3 and 2, one of the values there, either the 3 or the 2 will be negative to suffer to satisfy the -6. But when added, it won't give me a +5. So I can't use those values. So I have to now rely on my 6 and 1. I now need to make whichever of them, negative or positive to fit what it is that I want. My middle number is positive. My middle number is positive. So it means that my result is going to be positive. So it means then that the bigger of the two number must be positive. When I'm adding and the signs are different, I subtract from the smaller and put back the sign of the bigger. So therefore, my bigger number must be positive. So I must have a +6 and a -1. Person who asked the question, can you see why I have a +6 and a -1?
Yes, sir.
So now that I have a +6 and a -1, meaning that I would have broken up. Oh, and let us check. +6 times -1 is -6. Check. +6 minus 1 is +5. Check. So it must satisfy both conditions, not just one. It must satisfy both conditions. If it does not satisfy both conditions, there is no way you can move on from that question. I promise you. You can't move on because there's going to be something that is, you're not able to factorize it. So it must satisfy those two conditions before you can move. So what I'm going to do is to break up my +5x into 6x minus x. And then I'm going to be grouping. And grouping will give me the first two in one. Story time. You always leave your middle sign outside. But when you do, you must factorize a negative sign from outside of here. And in factorizing that negative sign, the sign that you have right here is going to be flipped. It's going to be flipped. And in flipping, instead of having a negative sign, it's going to become a positive sign. See it right here, sir? And the second story to that is that whatsoever sign that is inside here must be the same sign that is inside here. So both of these must be the same sign. So why? If they are not the same sign, I will not be able to factorize. If they are not the same sign, I will not be able to factorize. And I must be able to factorize. Or else I'll defeat the purpose. Because if I'm factorizing and I can't factorize, it means that I'm already defeated the purpose. All right? So now, So now, I'm going to ask myself a question. What is common here that is common here? Answer is x. What is left? X plus 6. What is common here that is common there? You better say 1. 1 is a factor of everything, eh? So if you're not seeing anything else, check 1. 1 is a factor of everything. So 1 is going to be common. And then we're going to be left with x plus 6. Now I ask the question, what is common here that is common there? And the answer will be x plus 6. What is left is going to be x plus 1. Right here. So either one of these two or both of them equals 0. It means that x is equal to negative 6 or x is equal to positive 1. And those will be my answers to where my function f of x becomes discontinuous. Are there any questions?
No, sir.
No, sir.
All right. And I'm happy that you say no. And the ones who are not answering and there are questions.
Sir,
Yes, please.
so I can go over the flip with the sign.
What sign you want me to go over?
So like go up. So when explain about the flipping of the sign,
Mm-hmm. All right, no problem. I will. But just allow me to refresh your memory. Remember when we were doing in foundations of mathematics and we looked at the industrial equations. You remember that?
Yes, sir.
Did we look at this topic?
Yes, sir.
In foundations of mathematics, when we looked at the factor and remainder theorem, did we look at this topic?
Yes, sir.
Mm-hmm. I'm going to go through it now, but I just want to say to you that you see, when we do our topic before, we are building on it. I really not going to have the time to go over the things that we've done before. I will do it, but I don't want us to get into the habit of let me just refresh your memory of what it is that we did. And it's important for me to show you so that you don't think that it's two different things. When I show you, you may say, oh, is that sir? So I just want to show you. I'm not trying to embarrass anybody so you don't ask me more questions. That's not the point. I just want to show you that we've done it before. Where are you? So at least you can see and you can say, oh, yes, sir, it's true. We did do it before. And somehow I can't recall exactly where it's at because this was quite a while back. But I think it's coming up now. Right, here goes. In this here case, when we're trying to solve this equation, we ended up having to do some levels of factorization here. And we did a factorization. And here it is, exponential equations. Right, remember the prerequisite skills needed, factorization, logarithms, and indices. And what it is that we said here is that we were going to get our trinomial or quadratic equation right here. And remember, sir did a recall, multiply the coefficient, the number in front of, y squared by the constant, the one that stands alone. That is, it's going to be this 1 times this negative 4. See it right here, so it's equal to negative 4. And then sir said, no, we need two numbers. When multiplied together gives negative 4, but when added gives positive 3. That positive 3 inside the other. So the factors are going to be positive 4 and 1. And we went through, and we did all of these questions. We had some trickified questions inside of there, and we went through and we did a whole lot of factorization. So this topic involved factorization. So if so we did factorization right there. And I think Tanil alluded to it earlier.
Yes, sir. I said to explain it, sir. And
Right.
something else.
Right, in the polynomial functions, and just allow me to share that in our polynomial functions, we're using our synthetic division. when we would have gotten our quotient, in order to solve, we had to go and factorize. This was also to define the remainder. When we get the question that says solve, we have to go a little granular. See here, this one would have asked us to solve. This was a warm-up question, right? And it would ask us to solve. See the word here? Solve equals 0. So we had to go and use trial and error. See here? Same thing that Mrs. reviewing just now. You have all these notes. Guys, you have all these notes. You have every one of them. Trial and error. Tanil, is this the polynomial one you're talking about?
Yes, sir. Why you were just yes, sir. This factorization using logs.
Okay, all right, fine. No, I find it, so I can resend. Thank you, hon. Right? See here, x squared plus 2x minus 48. X squared plus 2x minus 48 equals 0. Now we're solving the quotient. So Tani spoke about this in class tonight when we was talking. So we have 3 sets of answers. See, the order, the degree of the polynomial is 3. So we ended up with 3 different answers. All right, we'll talk about the fact and the remainder theorem, and we went through. So the point I'm making is yes, we have done these before, and I really want you guys to be able to remember the things that we've done before. But nonetheless, let us go through this one again. X squared plus 5x minus 6, we're going to be factorizing. Not just factorizing. Not just factorizing. Not just factorizing. Okay, I did say it. So the function is undefined when the denominator is equal to 0. See the statement? This statement is very important, because I can't just I can't be given an expression, so to speak, x squared plus 15x plus 56, and say, we're going to put it equals to 0. It don't work so. I'm not allowed to take my what do you call it, my expression and just convert it to an equation. Illegal. Illegal. Not because you're my neighbor, it means that I can come over your yard and come pick mango as I feel. No. Not at all. If the mango hang over your yard, the neighbor can't stop you from doing it. Can't stop you. Right? But you can't pull up them gate and go over there. Yeah. You shouldn't pull their gate and go over there. Same thing here, so. The only reason why I set the denominator equals to 0, because I know it asks me for the function to be discontinuous. And a discontinuous function is one where the denominator is equal to 0. A discontinuous function is one where the denominator is equal to 0. See, right, so? Very important. And that's why I set all of this here equals 0. That's the only reason. Did I do stationary points with you? No. Stationary points is in this calculus topic here. You are again going to be faced with this topic, and that's it. And that's the point. You know, you better stop and talk about it now than than it come back to surprise us. In this year topic on the calculus, applications of differentiation, I'm still into unit 1. I don't reach unit 3 yet. Lord Jesus, I pray for strength, Jesus. Guys, we need to be moving fast. I have like about 4 units and I don't reach nowhere yet. All right, so in my preparations for you, read my stationary points. There is going to be another occasion where we get functions. I can't seem to find it. Where we get functions to factorize using the same sort of something here. These are just one set. Where we get functions to factorize, and that we have to go ahead again and use our factorization. See them here, so right? So the same factorization is there. I mean, you can't escape it. You can't escape it. All right. So I'm saying this to teacher again. No, that's simultaneous. So you can't escape it. It is everywhere. Factorization here again. Same thing that we're doing. Factorization, factorization, and more factorization. All right. So let's go. So I'm multiplying the coefficient of x squared by the constant. 1 times -6 is -6. I need two numbers. When multiplied together will give me -6, but when added will give me +5. So by +5, it must give me the middle number. It must give me the middle number. So I need all the factors of 6. The factors of 6 are 1 and 6 and 3 and 6. Factors of 6 is going to be 1 times 6 and 3 times 6. Right? Two numbers when multiplied together will give me 6. 1 times 6, 3 times 2. 1 times 6, 3 times 2. And interestingly, those are the only two sets of numbers when multiplied together that will give me 6. In mathematics, sometimes you have finite answers. And this is one of the finite answers we have. Finite means that you can count them. Infinite means you can't count it. You have an infinite number of hair on your head. You can't count it. You can't count it. I have a finite number of students in my class. I can tell you how many students are there. All right? So in this case, we have a finite number of factors. When multiplied together, would give me -6, but when added, will give me a +5. It cannot be -3 and +2, or +2 and -3. Can't be, because when I multiply those pairs, I'm going to get -6, but when I add them, I will not get +5. So 3 and 2 cannot work. So I have to go now to the 5 and 1. Sorry, 6 and 1. 6 times 1 is 6. But I need a -6, so it means that one of the values has to be negative. But my middle number is positive. So the bigger of the two numbers must be positive. So since I need a negative number, and the bigger of the two numbers must be positive since I need a +5, it means that my 6 is positive and my 1 is negative. So my factors are going to be +6 and the -1. So factors are +6 and -1. Right? Every time. Now, I am breaking this up into 6x and -1x. Teacher, 6x and -1x. Sir, but you never write the 1. I don't have to. I don't have to. All right? Then I'm going to be grouping first two in one bracket, the last two in the bracket. But sir, you know what I did? I put x² minus x. Oh no, come on, undo, copy. Yes, sir, that's what I wrote. Not a problem. Not a problem. You're still grouping to give.
Sir,
Yes, please.
sir, like, I get it, because I do what you do. I don't know how many know say that, but my issue is like, I did have an issue with the sign part. But I don't know, I figure it out. I don't know what I do. I don't know how I figure it out.
Well, I'm happy.
So I forget what I say. I know what to do, but I don't know.
Well, I'm happy to figure it out. All right, so I'm just doing the question another way by rewriting it with the -x first. So I'm going to be grouping. Now remember, when you're grouping, you know, as sir says to you, the first two in one bracket, once there's a negative sign that you leave out, you have to flip this negative sign here, and it's going to become a positive sign. Why, sir? Because if you have a negative sign right here and you multiply this negative sign by this negative sign, you're going to get a positive 6. We don't have a positive 6 where we started off. We have a negative 6. So that's why the sign is flipping. Sir, why is it flip? Okay, let me tell you exactly what it is that you're doing. You are now factoring out a negative sign. So you factor out a negative sign from x, you're going to get negative x. You factor out a negative sign from positive 6, you're going to get a negative 6. Sir, how do you know that? Because we can't understand this math business. Okay, thank you for asking. So in every positive number, there are two negative numbers. So in every positive number, there are two negative numbers. So I can go into a positive number and remove one of the negative numbers, but best believe that I'm going to have only one negative number left. So I'm going into my 6 to take out one of the negative numbers. So therefore, I'm going to have a negative number that is left. So how do you know that in every positive number there is a negative number? Because when I multiply two negative numbers, I get a positive number. When I multiply two negative numbers, I get a positive number. So I know that in every positive number, there is a negative number. All right? So that's where I'm at. Now, in this here case, I'm going to have negative x. In this case, if I do it this way, I'm going to have this here, and I have a positive sign in between. Not a problem. Really isn't a problem. Then I'm going to ask myself, what is common here that is common there? Your answer would be x. Your answer would be x. So I'm going to take out my x. All right, let me do this. So I'm asking what is common here that is common there? X. So I'm removing my x. What is left when I take out the x from x squared? So in every x squared, there are two x's. I'm taking out one of them, I'm going to have one left. When I take out the x from x, I'm going to have 1. What is common between 6x and 6? It should be 6. What is left will be x plus 1. So I'm saying to myself, no, how do I write this? This is the same thing as writing x plus 1 times x minus 6. X plus 6. But sir, not the same answer you get? No, that's not correct. That's supposed to be a negative sign. Then sir, not the same answer you get? Absolutely. So that's what I'm saying to you there, you know, if somebody wrote a question as positive 6x minus x, the 6x first, you end up with the same answer. And if you wrote the minus x first, yes, on.
Sir, do you say that the signs have to be same in the bracket?
Yeah. It's supposed to be a negative, sorry. That's supposed to be a negative 6 right here. That's the problem when you copy and paste. That's the problem when you copy and paste. All right, because I have a negative 6 up top here. This positive 6 times this x is going to be positive 6x. This positive 6 times negative 1 is going to be negative 6. All right, this positive x times positive x is positive x squared, and this positive x times negative 1 is negative x. So anywhere along the algorithm, you double check and you go back, it gives you the same thing what it started off with. So your algorithm must be the same. Watch me. X multiplied by x is x squared. X times negative 1 is going to be negative x. See it right here. So this is the same thing you're talking about foiling. This 6 times x is 6x. And this 6 times negative 1 is negative 6. So anywhere along the algorithm, you double check. You're supposed to get back to where you started. All right? And then I will continue with this. Either that is equal to that and so forth and so on. All right, Tati D. Is it any clearer to you know, honey bunches?
Yes, sir.
No question, Tati. You think you'll always remember this?
Yes, sir.
Nice. And now hear me out for the rest of you. Let me just think ahead. A little later on, when I'm moving to multivariable functions and single variable functions, factorization is going to come back. So I'm still expecting to see more factorization. Please, we need to do what we need to do, because the factorization is here to stay. Factorization is here to stay. All right. Okay. So as I said before, I have multiple questions. I have 42 minutes left, and I have to move on to my other areas. I have multiple questions here that I have done some solution. Just pick up some questions out to the back. I will send those questions to you in addition to the ones that we looked at earlier. And see, the prerequisite knowledge is factorization, and I'm giving you an example of how it is that we refresh your memory, how it is that we do our factorization. Let me just fix this thing here. I have OCD, so you have to see with me. All right. So I'm giving you this as your recall, so you can see what is happening. So we spoke about difference of two squares. I'm showing what a perfect squares is, and I'm also showing you how to factorize the difference of two squares. Let me just I have OCD here. It's a good thing or a bad thing, but take time with me. All right, so I'm leaving these two as examples for you to see what is happening here, the difference of two squares, and you also would have gotten your questions on your factorization that we just completed. So I'm jumping from here. All right, now strange. When it just not turn all of a sudden. All right, let us go. Oh boy. I don't think that me never call for you now. Me do just want to get one associate degree from CHC, and the next thing you see me for the integrated maths. How would you must something else happen on the screen? John Star. Don't be alarmed. It's not bad. Let's go. Don't blink. If you blink, you can miss it. And I guarantee that you will get it. After the first example, I guarantee you will get it. Watch me. It says determine if f is continuous at x equals -2 and x equals +2. Given that f of x is equals to all of that function there. You know, thank you, Lord. Something just came into my spirit a while ago. And I'm gonna extend it to you guys. All right, so I'm teaching business calculus on a Saturday morning between 8 and 12. And it so happens that this is where I'm at with the business calculus students. And based on where I'm going to be going next with them is what I'm going to be doing with you on Friday. I'm going to ask that for those of you who can make it, I'm going to extend an invitation to you. I just need to tell the students beforehand that you can pop into the class on Friday to get, on Saturday morning, sorry, to get some additional help with the questions. Meaning, you're going to come to the class, to the business calculus class, to observe. Yes, you can answer questions. I mean, you can ask me questions in the class, but it's just an additional avenue for you to get extra help so that when you come back to your regular class, you will understand even better what is happening. So what I'll do on Saturday morning, I get the links every day. So on Saturday morning, God's willing, I'll post you the link for the business calculus class. Very nice set of students. I'll let them know beforehand that I'm inviting some of my other students to come in. And you come in and you see this stuff. You may see some of these things that we've done before. I normally do a review of the class. And I did piecewise function with them on Saturday. So you will see this piecewise function again as a review, and I'll be moving to other areas. So it's very important that you do this with me. And, you know, I think this is also the Lord speaking to me now. I may have to do that. I'm not teaching business statistics this semester, but I know my team members who are teaching the business statistics. I'm going to be looking at what it is that they're doing, and I'm going to see if I can create a link or, send a link out to you so that you can join that business statistics class. So at least you can see some of the statistics beforehand until I get there. All right. It's going to be very important. I'm finding ways in trying to complete the syllabus. All right. That was your public service announcement, brought to you by the ECC. Let's go. So we're going to determine if f of x is continuous at x equals -2 and x equals +2. Given that f of x is equal to all of this, now don't worry about this. Don't worry about this. It's called a piecewise function. It's called a piecewise function. Piecewise function. Huh? So it means that my functions are in pieces. And my function f of x are in 3 pieces in this case. Piece number 1 is 2x minus 1. I'm going to pay attention to this, get no hard. The business calculus, we just got it in about 45 minutes. Let's go. We don't have 45 minutes, but let's go. 2x minus 1. And I want to see the condition. The condition is x is less than -2. Now remember, when we speak less than, about less than is to the left or the right. Answer. Think of a number line. Less than is to the left or the right.
Left.
Very good. Very good. Left begins with L. Left begins with L. L and L. Not H-E-L anymore. Talking about the letter L and L. Left for L and right is greater than. So left is less than, right is greater than. So what this one is saying here is 2x minus 1, where x is less than -2, and x minus 3, watch this, where x is greater than -2, but less than or equals to 2. So the condition for x right here is going to be greater than -2, greater than -2, yes, I'm correct, or less than or equals to 2. And in this last piece here, x minus 1 is going to be greater than or equals to 2. Now I want to point out something. We have the time for you to investigate tonight. I wanted to point out something. You notice them two numbers are the same on the right hand side, yes, sir? And on the left hand side, them two numbers are the same. Yes, sir, I see it. There is no way I can give you -2 here, so I can give you 5 right here in order to talk about continuity. If the function is going to be continuous, it has to be continuous. So where this left off, this pick up. Where this left off, this pick up. Right? That's what we're testing for continuity. So look at what is happening. I now need to investigate these two places. It asks me to determine if the function is continuous at x equals -2 and x equals +2. So we then get them -2 and +2 here from here. -2 and +2. Now, if the function is continuous at x equals -2, I'm going to be looking at the function that deals with x being -2. So -2, I must look to the left of -2, and I must look to the right of -2. For the definition of continuity, notice remember I said to you, to the left is going to be superscript negative, see here, so superscript negative, and to the right is going to be superscript positive, see here, superscript positive. So I'm investigating what is to the left of this -2, and I'm also supposed to be investigating to the right of -2. Sir, okay. Remember we're doing the intuitive approach, and we spoke about what number we at. This number is at 22. When we spoke about the intuitive approach, and I had to look at the left-hand side of 1 and the right-hand side of 1, I had to look to the left-hand side of 2, and I had to look to the right-hand side of 2, and I looked at the left-hand side of 5 in this case, but this was the calculations method, and I looked to the right-hand side of 5. So what I'm doing, I have to look to the left and the right of the numbers I have to look to the left and right of the numbers in order for me to be able to see whether or not the function is continuous or discontinuous. So I have to look to the left and right. Watch me. I'm looking to the left of -2. See it yourself? X is less than -2. Less than is left. So this function is a function that corresponds to the left. There's no other function in this piecewise that corresponds to the left under this one here, ERE. All right? So I'm going to write it down, 2x plus 1, 2x minus 1, I'm sorry. So we're using the intuitive approach somewhat right here. But in order to evaluate the limit, we're going to be using a calculations approach. So my piecewise function includes both intuitive and the calculation at the same time. So anywhere in a function I see x, I'm going to put -2. So this is 2 times -2 is -4. -4 minus 1 is -5. So I'm going to take me to that one there. How are we going to do the one to the right of 2 now? Okay, good. Watch me. We're reading inside out, as I told you, x is greater than -2. We now look on this 2, because the 2 are positive. We're investigating x is equals to -2, so we can't look on +2. We have to only look at -2. So we're not even looking at the left, the right-hand side of this limit. So we're going to say x is greater than -2, but greater than is to the right. So that means the function, the only function in this thing that deals with to the right is going to be x plus x minus 3. And that's why I have x minus 3 right here. That's why I have x minus 3 right here. Anywhere in the function I see x, I'm going to put -2. -2 minus 3 is -5. So what it means then is that the function here from the left tends to -5. From the right, it tends to -5. If we were using the intuitive approach, we would have said the function is of a good behavior because the left-hand side is equal to the right-hand side, so therefore the limit exists at that point. Because we'll graduate from little school to big school now. Hold on. All right. Because we graduate from little school to big school, what we're going to say is the limit as x tends to -2 to the left is going to be equal to the limit as x tends to -2 to the right. So therefore, then f of x is continuous. Then f of x is continuous. Then f of x is continuous at x equals -2. So why is it continuous again? Because them two numbers there equal the same. Then sir, suppose they're different. Well, they're discontinuous. Because if it is not continuous, remember I drew the graph? The opposite of being continuous is discontinuous. All right? So if it is not continuous, it is discontinuous. If it is not open, it is closed. All right? Now, go ahead, please.
So say just look the values that they give you for f of x, so just looking which one of them corresponds to -2, and then you substitute -2 into the function.
Yes, please. Let's just look, no, let us investigate what happens to x equals +2. At x equals +2. We need to investigate here also. No. Can I use this function any at all?
No, sir.
Why? Because?
Because is it because x is less than -2?
Yeah, it has a value of -2. We don't want -2, a +2 we want. So we know we must use this because it's a +2, and we can't use the left hand piece of this. We don't have to use the right hand piece. X is less than. Oh, Oh, I see now, sir. So this portion of this double inequality now is going to be the x less than 2. And this down here is going to be the right-hand piece where x is greater than 2. Yes. Yes. All right. So to the left of 2, remember, less than or equals to represents less than. So to the left of 2 is going to be when x is less than or equal to 2. What, sir? If it is equals to, if it has an equality sign to it, it makes a difference? No. It only makes a difference when it's sketching the graph. The inequality sign, the equality sign to it only makes a difference when we're sketching the graph. Then sure, we have to go sketch graph too? Absolutely. What do you think you hear from? Sketching graph also. All right. And then now, when you look to the right of 2, the right of 2 is when x is going to be x minus 1. X minus 1 is going to be greater than or equal to 2. So because it's greater than, it's going to be to the right. Remember, less than is to the left, greater than is to the right. All right? So therefore, I'm going to have my x minus 1 is going to be to the right of 2. Similarly, anywhere in the function, I must identify the functions first. Once I identify the functions, I'm going to substitute the values there now. I'm putting 2 into x minus 3. 2 minus 3 is minus 1. And I'm putting 2 into the other function. 2 minus 1 is going to be 1. Are these two numbers the same?
No, sir.
So therefore, what is the
It's
conclusion?
discontinuous.
It is discontinuous. All right. So what I can say is, since the left-hand side is not equal, assigning me not equal to the right-hand side, then f of x is discontinuous at x equals 2. You see, because I want to equal, equals mean continuous, not equals mean discontinuous. Don't ask me questions. Is there anyone in the class that has not seen what it is that I did? Scratch that. Is there anyone in the class who just understands some of it?
Sir.
Okay, yeah, I'm hearing the yeses. The yeses to what? That you're understanding it, or you understand it? Okay, good. So what about those students who are not responding? Are you understanding what sir is doing or has done? Okay.
Sir.
All right. Don't answer that. Don't answer that.
Sure.
You're not sure. All right. Don't answer yet. All right. You're not sure. Let me just give you two stories. I'm going to tell you a story. Yeah. When I tell you the story, I'm going to see if you really understand it by giving you one on your own. All right. Hear my story. To the left means less than. I told you this before. And these are things that I come up with so that you can understand what we're doing. To the left means less than. Answer the less than sign here. Less than, it close, and then open up in the opposite direction. And it's going to be negative. That's what it is, negative. To the right means greater than. See it open up to you and close to the other end. That's what greater than is. Look at what is interesting. And you can call me boring. I don't have a problem. When me go to school, me study smart. Me not study hard. Me study smart. You see the L and the L, yeah? The marriage. You see the right? See the R and the R, yeah? Marriage. So right is greater than. Left is less than. And you can't forget this now. Left, less. And look at one way of looking at it again. we normally start with the left-hand side first. Oh, so because we started the left-hand side first, them two letters are started, don't? Yeah. And watch this. The R ends it. So we look at the left-hand side first, then we'll go to the right. So how you know we always start to the left-hand side? Because we read from left to right. Stop and think back to the number 9. X tends to -2. Superscript negative means X tends to the left of -2. That's what this means. X tends to the left of. That piece up here means left of -2. And a 1 here, X tends to -2 plus superscript means X tends to the right of -2. When you get a double linear inequality figure or your inequation like this, you always read inside out. You start at the X. You start at the X and read to the left. You start at the X, then read to the right. Start at the X, read to the left. Start at the X, read to the right. X is greater than -2. And X is less than or equal to +2. We did this already. We did this already in inequalities. Nobody should say, sir, I don't understand this. This was previously done in inequalities. Is read X is greater than 2 and X is less than or equal to +2. Since we read from left to right, once the inequality sign is open to you, then it is going to be greater than. See here? It opens, it's going to be greater than. In other words, the mouth of the alligator is open, bam, it's greater than. Otherwise, it is less than. The mouth of the alligator is closed, bam, is less than. So these are some little things that you can pick up. All right, you can pick up. Now let me just tell you a secret. I am sure, positive, when Mrs. Henningham was going to school, teacher never presented the information like this. I can tell you when I was going to school, my teacher never presented information like this. But guess what? In an era where it is that we have to teach online, where it is that you're not seeing what is happening, we came up with something that is very, what we call granular. We'll go down point by point, nitty-gritty, so it is that we can bring across the points to you. What's the point, sir? Don't just get the notes and sit down on it. Read it and try and understand it. Let me ask a question. How many of you, when I post the notes in WhatsApp, would download, print, and have it a physical copy to look at? Okay.
Sir, can you repeat what you said, please?
I'm asking how many of you, when I submit the notes via WhatsApp, would print it and have your printed copy looking at? To look at. Okay, so you write it. Okay, very good. Okay, that also works. How many of you only just use the electronic version of the notes? Okay, nobody. Okay, yes, Natalie. Okay, Natty D, I see your hand. All right. Tati D, I see your hand also. All right, good. Whatever works for you. I am not being prescriptive here to say you have to print the notes. I know time's hard. And printer, ink, and paper. Yeah, I know time's hard. Whatever works for you. If you can afford to print and have your stuff, it doesn't mean a thing to Mrs. Henningham nor myself. If it means that you can rewrite the notes for yourself and it makes it etch into your memories even better, it don't mean nothing to us. And if it is that you prefer to have the electronic version, it don't mean nothing to us. What it means is that whichever of the 3 methods works for you, work it. Work it. Work it. What is overwhelmingly true is that a good portion of the class is not revising the way we're supposed to be revising. It's very evident what Mrs. Henningham is doing and the level of repetition she has to go through class by class. It is very evident that the class is not revising because areas that I've already gone through and trying to build on, I have to pause and recall. That is taking up time. But I have no problem recalling because if it makes you grasp the information that we did before better and the one that is being presented faster, not a problem. But I'm saying to you guys, this is a point at which now you're going to gather your notes. If that church and start seeing gather Christian coming to celebrate, right? But gather your notes and start working. All right. With that said, I know you don't like when I use this view, but I'm using this view because I want you to be able to, oh no, oh no. If I do that, you're going to see my answer. I don't want to see the answer. I want you to be able to try it on your own. I have this question. Ignore the sketching of the graph. We'll soon get there. I have that question. Determine if g of x is continuous at x equals -4 and x equals +1. Then, sir, you can have the numbers like that. The question you gave us a while ago had -2 and +2. We can go -4 and +1. You can go anything. You can get anything. Just work with what you have. So you need to check to see if g of x, and see the function not f of x is there, and it's now g of x. Don't be alarmed by the change of the function, right? So if g of x is continuous, determine rather if g of x is continuous at x equals -4 and x equals 1, given that g of x is equals to this function here, all of this. We have a story to tell you. Let me tell you the story first. The limit of a constant is, hello? The limit of a constant is, oh Lord Jesus. I'm sure I've said this in class before. I'm positive this not, I'm not mixing you guys up. What is the limit of a constant?
Sir?
The limit of a, say it again.
Itself.
Thank you. The limit of a constant is the constant itself. Has anybody heard me say it in class before?
Listen.
So I don't remember.
Tan, yeah man. So the limit of a constant is the constant itself. The limit of a constant is a constant itself. Always remember that. You hear? The limit of a constant is a constant itself. So this piece here, when I find it, if I find the limit of this, it's going to be the same thing like this, 11, because the limit of a constant is a constant itself. All right, I'm going to give you 5 minutes. It's now 16 pounds. I'm going to give you 5 minutes just to dabble with this question, and then I'll come and go through with it. I just want you to get your hands dirty. 5 minutes or 3 minutes. Start.
Sir?
I'm right here, hon. Go ahead.
Oh, I was saying that I'm finished.
All right, good job. The rest of you, how far are we?
Finishing.
Oh, nice. Is it continuous at x equal -4?
Yes, sir.
Yes, sir.
Okay. Is it continuous at x equals 1?
Yes, sir.
Yes, sir.
Oh, so you're saying that it's continuous both places. All right, let us check to see. So it says we're investigating at x equals -4. So we're looking to the left and right of 4. So we need to look to the left and right. So we need to look for anything that is less than -4. The only function inside this piece here, in this piecewise that leaves it less than, is going to be a half x plus 3. So to the left of -4, -4 raised to the -1, or to the minus sign, is going to be a half x plus 3. See right here, so -4 raised to the negative sign is a half x plus 3. And then now to the right of -4, this other piece here, see, going this side, these at -4, x is greater than -4. Greater than is to the right, so to the right is going to be 2x plus 9. So that's why I have my 2x plus 9 here. Having recognized these, I'm then going to now apply the limit using the calculations approach. Wherever in the function I see x, I'm going to put -4. So watch me. It's going to be a 1/2 times -4 is going to be -2 plus 1 is going to be +1. And -4, yeah, -4 times 2 is -8. -8 plus 9 is going to be +1. So the function, because these two things are the same, see the statement here? I hear me say to you, important for you to write your statements. Yeah. So because of all of that, then f of x is going to be continuous. Then f of x is going to be continuous at x equals -4. So why? Because both of them are equal. So you're investigating to the left and to the right of the function. Now to the left of the function is 1, and to the right of the function is 1. We can conclude that the function is well behaved, right? But we cannot graduate now from being well behaved to that the limit as x tends to 4 to the left is going to be equal to the limit as x tends to 4 to the right. So yes, congrats, it is continuous there. Let us check the other one at x equals 1. Very good. So at x equals 1, we're going to be looking at the left of 1 and the right of 1. Which function in the piecewise deals it to the left of 1? See here? X is less than. Remember, less than is left. So x is less than or equals to 1 is this function. And x greater than 1 is 11. So we have these two functions. Now, when x is 1, 2 times 1 is 2, plus 9 is 11. The limit of a constant is the constant itself. So both of them are 11, so the function is continuous at x equals 1. You can't forget this recall. The limit of a constant is the constant itself. Always remember this. The limit of a constant is the constant itself. All right. Congrats to those who got it. Those who didn't get it, are you seeing where you went wrong?
So I have a question.
Go ahead with the question.
When the thing is
Volume.
tending to
Can you start again? No. I'm hardly hearing you. Can you go again, please? Volume.
when x is tending to the sum on the bottom, the little small part, right? It's tending to +4. Why isn't it 2 and then +4 plus 9?
What? I don't have a +4, I have a -4.
Yeah, I know, but isn't it tending to +4?
Weird, don't hear so? No, it's -4.
Sorry again.
I'm bigifying it so that you can see it. You said +4, but I'm not seeing a +4 with my question, so I'm trying to find out where you are.
Oh, okay. That's well.
Okay. Any other question?
No, sir.
All right. We have 3 minutes. I'll give you an easy one. Determine if R of X is continuous at X equals 3. Sir, other one I have 2. Some of them just easier than others. Determine if R of X is continuous at X equals 3. I'll give you 2 minutes for this one.
Finish, sir.
Continuous or no?
Discontinuous.
You sure?
Yes, I'm sure.
That's not correct. It's not correct. Anybody got it to be continuous?
Sir,
Sir, I said discontinuous.
Continuous.
Sir, I don't believe you
I
anymore.
love the confidence. I love the confidence, and that's how you must be confident. I love it. Hold on there. Yes, go ahead.
I mean, I say you can't. We get used to that style, you know.
Exactly. I can't follow no more.
Okay then. All right. I forgot. Mrs. Henningham, I need a new style. Them know my style. Them know my ropes. All right, very nice, guys. This is what I'm saying to you. The business class plus students got it in 45 minutes, and you got it in less than 45 minutes. This is, I knew you really get it. The question on the card, but in the heart. All right. All right. It's now 28 minutes to 9. Going to be true to your time. I'm going to be sending you. Because I want you to do. I don't want to keep you per se in class, but I'm going to challenge some of you to continue working on on this. So I'm gonna send you some other questions, like I have some do now here for you. I'm gonna send you. Do you want me to send you the solution, or you want to just do it on your own and then I surprise you with the solution next time around?
Do it on my own.
Do it on our own.
Do it on your own. Okay. I hear
So
do it on
a
your own
question in
first.
the chat.
I use a question in the chat. Do it on your own first, James. I'll send it. Okay. So remember now, it is continuous when both answers are the same. You notice in this one here, we got -3 to be 1, and them are going in two different directions. Two different directions. The one at -3 and the one at 0, them not sing the same song. Mommy, can I go to the party? Okay, dear, you can go. Daddy, where are you going? To the party? No, you're not going. But mommy says, no, I can't go. You are not going. These are this continuity in how it is that you talk to the child. So mommy and daddy now needs to come together and they say, mommy, can I go to the party? Yes, you can. If your father says yes. Daddy, can I go to the party? That boy down the road going to be there? No, daddy, it's not that kind of party. Okay, yes, you can go. Both mommy and daddy, come together. So there's agreement with what it is that you're saying to the child. Yeah. So they have to be the same in order for it to be continuous. Once they are different, they are going to be discontinuous. Just remember that. Just remember that, right? And remember also, the limit of a constant is the constant itself. That will not change today, tomorrow, or whenever. Have a good one. Remember to say gentle Jesus and sleep tight, be nice, be safe. And I'm going to send you some stuff in a few minutes' time.
Bye, sir.
Bye, sir. Bye.
I didn't see that message in the chat.
Sorry, I looked at the chat.
Oh, okay. Bye,
All right,
sir.
thanks. Goodbye,